Hello guys, welcome to the meeting. So in this video, we are creating a basic functionality in the game. So have you guys ever wondered why Hollow Knight or Mario make the player stick to the wall instead of instantly falling like this? So we are simply detecting a wall and limiting the player's falling speed. So first, let me delete these and move the wall to here. I will increase the size of the wall. Yes. And this. So we will create a layer which will be named as wall. And this should be the layer wall and this also. So now let's move to the code part. Here we will create some variables. First will be realize field private float while check distance. This means how far our Raycast ray will travel. We will keep it as 0.5x. Then serialize field private layer mask wall layer and one more serialize field private float. Okay, there is an error. Float wall slide speed, which will be our viewer, and then extra variables will be private bool edge touching wall private bool edge wall sliding. Okay, so this means am I touching the wall, and this means am I currently sliding. Okay, uh, we will create the raycast for our sliding. So edge touching wall equals to physics 2D dot Raycast will pass the parameters. First will be our starting point, which will be transform dot position, then the direction, which will be vector 2 dot right, and then we will multiply it with transform dot local scale dot x, and then wall check distance, and then wall layer. Okay, so let me explain this. Our starting point is transform dot position, direction is vector 2 dot right in the right direction, but we can't rely on transform dot position anymore, because we are flipping our player. So we also need the direction it is currently facing. By the help of transform dot local scale dot x, we can get the direction, and then we will start the rain. So if we are currently facing right, then it is this direction, left. So in this direction, -1 will be the local scale value if left. So it will be multiplied by the direction. Okay, next. Okay, I guess should we, after the jump, if it's touching the wall while creating the wall sliding mechanism and not grounded, and move input dot x not equals to 0. So if our player is touching the wall, if our player is not grounded and move input of x is 0, then we will wall slide. So this means not, and this means not equals to. Okay, that this is wall sliding equals to true, and else it's wall sliding equals to false. Okay, so must touch the wall, must be in air, and player must be pushing towards the wall. This keeps preventing us by, if our player is near the wall, so then it will slide if we don't add this line. Okay, now the fall, if edge wall sliding, then RB dot linear velocity equals to new vector to passing the new vector, which will be RB dot linear velocity dot x keeping the x velocity same, and then y velocity will be modified, which will be wall slide speed. So our player is currently falling from the air, and if we don't add the minus 2, sorry, uh, 2f speed, so when our player will fall, it should be uneven. So we are adding a constant speed and a slow speed so that it will feel smoother when our player is sliding the wall. Now this is okay. Now the last part is the Gizmos one. We'll add the color to our Gizmos. First Gizmos dot color. Let me copy this line. Color will be blue, and then Gizmos dot draw line, which will be starting point, transform dot position, then transform dot position plus vector c dot right direction, uh, multiply this with transform dot local scale dot x, and multiply this with wall distance. The board starting point, the direction, and with the length of wall check distance. Let's save the code. We'll go to Unity. Okay. Now physics transform dot local scale. Yes, this is right. Then should be small like this. Then it should be small here also. Uh, Transform does not exist the current points. Okay. That is it. Chance. Oops. There's a typo. Is solved now. And then here, new vector 2 from here. There should be a space between these, keeping the Romeo and Juliet together. a bit. Okay, now our code is error free, I guess. Okay. Yes, it is. Now I will play the game. Forgot to one thing. Add that this wall layer is our wall. Okay, so the ray is a little small. Modified to 0.8, too big, 0.7, 7.5, 7.1, 7.2. This 7.2 should be fine, I guess. Let's play the game again. Something wrong with Unity? No. Okay. I guess there is an error because our Raycast ray is not changing its position. Maybe okay, okay. Should we after the should we here? So we will add some things because here you can see we are flipping our sprite only, but we have added transform.local scale here. So this is the reason player was not while sliding correctly. So we will add now vector to wall direction, and then if sr dot flipx, then wall direction is vector 2 dot left, and else wall direction is vector 2 dot right. So If our player has flipped, then the direction of wall direction is left, and if it is not, then direction is right. Now we will update it here. Just remove these things. Wall direction, save it. And inside these, add wall layer to wall. Okay, max jumps is 2. We will add one thing also, same as this will be for gizmos too. So inside this vector, let me copy that. It will be vector 3, and we will name it as gizmos direction, and then gizmos direction is vector 3, and here also gizmos direction is vector 3 dot right. Inside here, transform dot position plus, we remove this and add gizmos direction multiplied by wall check distance. Okay. Now the Raycast can move to left and right. Okay, he is moving. Uh, Let us debug that. Debug.log each wall sliding and let us also print if it is touching the wall or not. It's touching wall, you will print this. touching the or while sliding is happening, but we need to also consider the touching the wall. Okay, yes, everything's fine. If we freeze this, let's see what happens. And see when I'm touching the wall, it's sliding very fast. So, okay, that's it for today, guys. Bye bye.